So let's start off with the third lecture, and here we are going to talk about the chemical and the electrochemical energy. Now this is a unit which we have done before because we have studied a lot about batteries. We had an entire unit on this. So when we talk about batteries, we are talking about storing chemical energy and later on getting converted into electrical energy. So here also we are going to look into some of these batteries. So this might be a kind of revision for you all who already know about batteries. So if before we start, let me just give you some brief idea about chemical energy storage. So the most common example, as I said, for a chemical energy storage is something which is called the common battery. So the battery that we're using in our daily to day life and nothing but the chemical energy storage. Okay, and then if we talk about something like an electrochemical energy, that is also a part of this. So by using the liquid inside it to store electricity, it can release as is required. So we have the electrolyte, if you remember, okay, and then that liquid actually is the source of generation of electricity because of the chemical reaction that happens with it. So if you consider a very large battery, that can actually act as a chemical energy storage for industry. So if we have something on a larger scale, for example, let's say the power plant, and you want to store a large amount of energy, you need an enormous system of batteries. Now that becomes a kind of difficult, and as we proceed, we'll tell you that there are actually some drawbacks related to these things. Okay, and then but then if that can be achieved, we have a large battery storage for chemical energy that can actually make future energy generation solution more efficient and profitable. Okay, so we can have a backup system and so on. So this will be achieved. How can we achieve this? This can be achieved by storing energy generated when demand on the grid is low and releasing this as required to help meet peak demand. So what happens sometimes, we don't have that much of demand, but the grid is generating electricity. So instead of sending it out to the system or to the household or to the transformers and so on, okay, we are going to just store it in the power plant itself and then going to release it from there whenever the demand goes high. So might be daytime we can store, nighttime we can release and so on. So different ideas can be there. So if we want to store the chemical energy in battery, the battery usually consists of three components which we already know: the anode, which is the negative pole, the cathode, the positive pole, and of course the electrolyte, which is the chemical in which the oxidation or the reduction reaction takes place. So we have the chemical that produces the flow of energy. See, this chemical produces the flow of energy, and the cathode and the anode are known as the terminals and are made up of metal, which is then separated by the electrolyte. So in general, when we consider a battery, we know there is a positive terminal, there is a negative terminal, and these are nothing but the anode and the cathodes. So the first thing is conversion of stored energy to electricity. So we are here converting the chemical energy to electrical energy, but the reverse is also possible. We can also convert electrical energy into chemical energy, which I am going to talk about in the next slide. So what happens is when the battery terminal is connected to a device, let's say a bulb for example, and we have the battery charged, the bulb will actually drain out the electron, as a result of which it works. So this is a very simple thing. What happens is the chemical on the anode causes a release of electrons to the negative pole. So anode is very important. It will actually release the electron. Okay, and the ions in the electrolyte. Okay, so this ions which are actually generated in the electrolyte. Okay, and then we have got the anode. Okay, and so this is basically what is happening here, the negative electrode, and then the ions are also there. So ion is also basically nothing but energy carrier or the charge carrier. So this is the chemical oxidation reaction which we have studied. What happens on the positive pole? The cathode will accept the flow of electrons, and in between we have connected the bulb. So basically this will actually complete the circuit for the flow of electron. Now these two reactions happens simultaneously. Okay, what are the reactions? First is the ion transport through the electrolyte. This remains within the system, and the electron flow in the circuit. So electron flow in the circuit, and this will actually generate the electricity. So this is something which is very brief. I think we have studied it in more detail in the chapter of batteries. So this is basically a chapter where we are revising a unit or a topic which we are revising a lot of things. So how do we convert this electricity to chemical energy? So we can do this in the form of something which we call as a rechargeable battery. So you're having a lithium-ion battery in your camera, in your mobile and so on. These are rechargeable. So that means you are using electricity to charge it. So basically you are storing it to chemical energy. Okay. So the process of battery storage basically reverses and transforming electrical energy into chemical energy. So what happens is when excess electricity is produced in the grid, it can be channeled into a battery system, and that can be stored in the chemical system. Okay, so we can have it in the electrolyte, stored in the electrolyte. So basically the mobile phone and the electric car, which I told you, takes advantage of this system, and we have got a rechargeable battery system. Now what's the future for this? The future is when electricity is produced by intermittent renewable sources like wind or a solar PV, it can be stored in big industrial sized batteries. But is that feasible from commercial point of view? That is something which we need to see. Okay, but that is actually something, that is why I'm saying it's the future. Okay, it's not really something which is conducive at this moment because of the cost and other factors, but definitely that can be a solution for the future, where we can actually store that excess electricity into rechargeable batteries. But there are different kinds of batteries for the mass energy storage. Okay, so we have already seen these batteries or talked about these batteries before. Some of the most common batteries that are used for energy storage are the lithium-ion batteries, the lithium-ion polymer batteries, the lead-acid batteries, flow batteries, and sodium-sulfur batteries. But I think in lead-acid batteries we have also discussed the different kinds which are actually there present. Okay, so we're just not going to look into the internal structure of battery. We're just going to talk about a brief idea of how the energies are stored or what are the applications and so on. That is the aim of this particular unit. So first let's talk about the lithium ion battery. Now lithium ion battery is the most common type of battery, the fastest going battery type. Okay, this is rechargeable in nature, and Sony company is one of the pioneers in designing these kind of batteries. Okay, so what are the uses? The uses are definitely in laptops, mobile phones, and of course the hybrid vehicles, due to the high amount of energy that they can store. So for any kind of battery, if you want to make it commercially usable, first of all it should be cheap, affordable, and at the same time amount of energy or the energy density that it has should be high. So high energy efficiency operate well under a wide range of temperature. So that means even if the temperature keeps on varying, that should not affect the system. Okay, and they can be recycled and also have a low level of self discharge. So these lithium ion batteries has got all these properties. They are actually able to work in higher temperature or lower temperature as well, which is not the case with lead acid batteries. So if we actually employ this as a grid storage solution, these type of battery will require some refinement. So we need to redesign it, okay, need to change few things there, okay, and that will need to operate with improved lifespan. So what happens is these lithium ion batteries might have a definite lifespan. That means you can recharge it for, let's say, 1000 or 2000 times, but not beyond that. But if you are considering it in a power grid system, the lifespan has to be much more. So that means the research still needs to be continued to look into it. Okay, and definitely the safety. So you might have heard a lot about these things, that a mobile phone has, the battery has blasted or it has just gone off. Okay, and then it has overcharged and something some malfunctioning has happened. Now this is something which is not safe. So this is something which we don't want. So the safety is also something which needs to be looked into. Most importantly, the cost to produce the lithium ion battery needs to come down. So if you go to purchase a lithium ion battery or any rechargeable battery, you see that it will usually cost higher compared to normal batteries which we use. So that means the cost is quite high, and this needs to come down so that this can be used. Otherwise what happens is your electricity bill is going to go high if these kind of batteries are employed into the system. This is not a problem, a region problem. This is basically a worldwide problem. Basically a worldwide research is being conducted on such topic. Next we have got the lithium ion battery, polymer battery. Now compared to a lithium ion battery, lithium ion polymer battery will have a better energy output, a good safety record, okay, and it is also having a longer lifespan. But again, this is also uneconomical to produce, so the production cost will actually need to come down to make this viable to as a mass produced storage solution. So that our electricity bill doesn't go high, employment of such batteries right now is not feasible in the commercial scene. What about lead acid batteries? It can be designed to power large applications and are relatively cheap, safe and reliable. So they are cheap, they are safe, they are reliable, but they have other issues. Okay, they are in fact the only one which are already being used in large storage and uninterrupted power supply solution. So basically consider your emergency lighting or let's say an inverter which is placed at your home, or the backup generator. All of them are basically using the lead acid batteries, which means they can be increased further in size to power grids. But see, there is a problem. They they actually are very large and heavy and immobile. So these lead acid batteries are large, heavy, immobile. So transportation becomes an issue, okay, and at the same time they have got poor cold temperature and performance and a very short life cycle. Okay, so this is the problem with this. These are the drawbacks. Okay, these are the drawbacks. But one of the positive thing is they can be easily recycled, and an infrastructure around this process already exists. So basically these things are already in use. The lead acid batteries is already into the system. They are already used, but using it on a even larger scale to actually put it as a backup for electric grid becomes difficult because of the transportation issue or the storage issue, and then they have got a poor cold temperature performance, and the life cycle is also not that high for our liking. Okay. Next, flow batteries. Flow batteries is also there. Okay, and this is unlike a conventional battery. The energy output is independent of the energy storage capacity. So it might store lesser energy, but the energy output might be high, or it might be storing a very high amount of energy, but the energy output can also be controlled at the same time. Now the output depends on the fuel cell stack. So basically they are composed of fuel cells. So let's not discuss fuel cells right now, but in brief we can say that fuel cells actually can store much higher amount of energy compared to normal batteries. Okay, so the energy storage depends on the size of the electrolyte tanks, and these are independent from one another. So there are different separated tanks out there. Okay, and this energy storage will depend on how much big the size is of that tank. Okay, the operating capability is very useful when large current flows needs to be transported to a national electricity grid system. Again, the energy output ratio to the weight can be up to 3 times better than lead acid battery. So it is having a higher performance. The energy output is more, but the weight is less, 3 times less. So that means it's mobile and it's more easy to carry around. Okay, and they also have lower energy efficiency. But the problem is the energy efficiency might be slightly lower compared to that. Okay, but at the moment these are actually only on the experimental stages, and they are not used commercially as of now. So we hope in the near future these can be used and some of the issues can be looked into. Next we have got the sodium sulfur battery. Now we know that sodium sulfur, basically we are talking about a salt. Okay, so a sodium sulfur battery is a type of molten salt battery that constructed from liquid sodium and sulfur. It has basically got a very high energy and power density. Now if I give you a question on finding out the or stating the difference table, you have to just look into these points separately and try to understand what is the basic difference between these 4 or 5 kinds of battery that I am discussing. So this is very high energy and power density as a result of sodium being a high reactive alkali metal, and this type of battery has got a high energy density. The efficiency is also very high. Okay, and it has got a long life cycle, and the construction is also not very costly because this can be fabricated from some inexpensive material. The interesting part here is that the very high temperature is needed to operate such system, because we want that state to be molten, the molten salt state. So the temperature of operation is 300 to 350 degrees centigrade. Now this brings an additional problem. We need an additional energy to keep them operational or working. Okay, so another problem is highly corrosive sodium polysulfides are used, which is very much highly corrosive. These cells might be stationary, so that means we cannot move it around. In case the corrosive materials, sodium or polysulfide spills out, okay, this is going to damage the surrounding. So this is something which is again difficult to manage. Therefore they are ideal for energy arbitrage, okay, which is when the grid system fluctuates. So if there is a fluctuation in the system, okay, we can actually use these kind of battery system and supply, and the battery can help to manage the load. Okay, but then we have to look into the drawbacks as well. So what is the commercial viability of chemical energy storage? So let me just tell you this simple fact that chemical energy storage on a large scale is still not done. It is still in the research phase. So we are basically still far from producing batteries that are viable and cost effective solution to manage the variation in grid system. So if we basically consider a grid system, we are talking more or less about power plants. So huge amount of energy is generated there. So we need to look into the commercial viability. It would be definitely very expensive to make batteries capable of storing excess energy on the grid. So what happens is, if this energy storage solution was implemented, it may significantly increase the cost of electricity to consumers, which I already told you. And then the smart grids will require advanced utility scale batteries to store electricity so that it can deliver when needed. So it can store energy, but then we need to store a huge amount of energy. A single small battery doesn't have that much of capacity compared to the demand that is needed in our day-to-day life, even in industries or even in household power supply. So it's very important that we store huge amount of energy. Huge amount of energy calls for a large number of batteries. Large number of battery calls for a large number of amount of money. Okay, and then obviously it will increase the cost of electricity. So that's all for today. Thank you.